Hello everyone, I'm Professor Diwa and welcome to another math video. In this video, I'll be going over polynomial functions and adding and subtracting. Our objectives are to define monomial and determine the degree of a monomial, define polynomial and determine the degree of a polynomial, simplify polynomials by combining like terms, evaluate polynomial functions. Alright, so let's get started. First, we have the definition for a monomial. It states here that a monomial in one variable is the product of a constant and a variable raised to a whole number power, such as 0, 1, 2, and so on. A monomial in one variable is of the form ax raised to the k power, where a is a constant, x is any real number, and k, the degree, is a whole number. For example number 1, determine the coefficient and degree of each monomial. For part A, we have 3y raised to the fifth power. The coefficient is going to be the 3 in front of the y, and the degree is going to be the exponent on the y, which is 5. For part B, we have negative 3 over 2n raised to the second power. The coefficient is the negative 3 over 2 in front of the n, and the degree is the exponent 2. For part C, we have negative p. The coefficient for this monomial is negative 1, and the degree is going to be 1. It's understood when the exponent on the p is not written that it would be a 1. For part D, we have b to the fourth power. The coefficient would be 1. It's understood that there would be a 1 in front of the b to represent that you have 1b, and the degree would be 4. For part E, we have 6. The coefficient would be 6, and the degree would be 0. It's understood that when there's no variable, that the exponent on the variable would be 0. The reason why it's 0 is because any variable that has an exponent of 0 is equal to 1. For example, if we have 6x to the 0 power, x to the 0 power would be 1. We would have 6 times 1, which is just 6. For example number 2, which of the following are monomials? For part A, we have 5p to the third power, q to the second power. This would be a monomial. For part B, we have 2a raised to the exponent of 2 over 5. Now this would not be a monomial because monomials have whole number exponents. You could see here our exponent is a fraction, so this is not a monomial. For part C, we have negative 3y to the sixth power. This would be a monomial. For part D, we have 7a squared b to the 0 power. This would be a monomial. For part E, we have 8a raised to the exponent of negative 1/3 power. This is not a monomial because the exponent is a fraction. For part F, we have negative y raised to the negative 5th power. This is not a monomial because negative 5 is not a whole number. For example number 3, state the coefficient and the degree of these monomials in more than one variable. For part A, we have negative 2a squared b to the 5th power. The coefficient is just negative 2. To find the degree, we just add together the exponents. We have 2 on the a and 5 on the b, so we get the degree is 7. For part B, we have 9x y cubed. The coefficient is 9, and the degree would be 4. We have the exponent of a 1 on the x and a 3 on the y. 1 plus 3 is 4. For part C, we have 3x to the 5th power y squared. The coefficient is 3, and the degree would be 7. We just add together the exponent of 5 on the x and 2 on the y to get 7. For part D, we have 4a b to the 1/2 power. This one would not be a monomial. Next, we're going to go over the definition for a polynomial and the degree of a polynomial. It states here a polynomial is a monomial, or the sum of monomials. The prefix poly means many. Next, we have the definition for degree. It states here that the degree of a polynomial is the largest degree of all of the terms. For example number 4, determine which of the following are polynomials. Find the degrees of the polynomials. For part A, we have the polynomial 5a cubed minus 3a squared plus 8a minus 1. To find the degree of this polynomial, we just look at the term with the highest exponent. You can see we have 5a cubed. The highest exponent here is 3, so the degree would be 3. For part B, we have the polynomial 5 minus 6x plus x squared. The highest exponent we have here is 2, so the degree would be 2. For part C, we have 3x to the negative 2 power minus 6x. This is not a polynomial because the exponent on the 3x is a negative 2. We can only use whole number exponents. For part D, we have m cubed n squared minus 2mn cubed plus 3m squared n. The term with the largest exponent would be the m cubed n squared. To find the degree, we just add together the exponents on the m and the n, which is 3 and 2, so 3 plus 2 is 5. The degree would be 5. For part E, we have the polynomial 5b squared minus 3b plus 11b to the 1/2 power. This would not be a polynomial because the last term has a fraction as an exponent. For part F, the degree would be 0. For example number 5, find the sum. We have parenthesis 5x squared y minus 3xy plus 12xy squared close parenthesis plus parenthesis x squared y minus 12xy minus 5xy squared close parenthesis. In order to find the sum of these two polynomials, we just drop the parentheses and then we combine like terms. So we have 5x squared y plus x squared y minus 3xy minus 12xy plus 12xy squared minus 5xy squared. So you can see here that I grouped together all of the like terms. Next, we go ahead and simplify. So we have 5x squared y plus x squared y is 6x squared y minus 3xy minus 12xy gives you negative 15xy. And then we have 12xy squared minus 5xy squared is positive 7xy squared. So the final result is 6x squared y minus 15xy plus 7xy squared. Next, we have a practice problem. Find the sum, parentheses 6a squared b plus 11ab squared minus 4ab close parenthesis plus parenthesis a squared b minus 3ab squared plus 9ab close parenthesis. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to verify your answer. Alright, so let's get started. So first I grouped together all of the like terms. We have 6a squared b plus a squared b plus 11ab squared minus 3ab squared minus 4ab plus 9ab. Next we go ahead and simplify. 6a squared b plus a squared b is 7a squared b. 11ab squared minus 3ab squared is positive 8ab squared. Negative 4ab plus 9ab is positive 5ab. The final result is 7a squared b plus 8ab squared plus 5ab. For example number 6, find the difference. We have parentheses 2a squared b minus 7ab squared plus AB close parenthesis minus parenthesis 5a squared b plus 6ab squared minus 4ab close parenthesis. To find the difference between these two polynomials, what we need to do first is distribute the negative inside the parentheses to the second polynomial. We get negative 5a squared b minus 6ab squared plus 4ab, and then we can bring down the first polynomial. So the result is 2a squared b minus 7ab squared plus ab minus 5a squared b minus 6ab squared plus 4ab. Next, we could go ahead and combine our like terms. So we have 2a squared b minus 5a squared b is negative 3a squared b. Next, we have negative 7ab squared minus 6ab squared is negative 13ab squared. And then finally, we have plus ab plus 4ab is positive 5ab. The final result is negative 3a squared b minus 13ab squared plus 5ab. Next, we have a practice problem. Find the difference. Parentheses 2p squared q plus 5pq squared plus pq close parentheses minus parentheses 3p squared q plus 9pq squared minus 6pq close parentheses. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over the solutions. So first off, I brought down the first polynomial, and then I distributed the negative inside the parentheses to the second polynomial. The result is 2p squared q plus 5pq squared plus pq minus 3p squared q minus 9pq squared plus 6pq. Next, we go ahead and combine our like terms. 2p squared q minus 3p squared q is negative p squared q. 5pq squared minus 9pq squared is negative 4pq squared. And then finally, pq plus 6pq is plus 7pq. So the final result is negative p squared q minus 4pq squared plus 7pq. For example number 7, perform the indicated operations. We have parenthesis 5x squared plus 2xy minus y squared close parenthesis minus parenthesis 9x squared minus 2y squared close parenthesis plus parenthesis 7x squared plus 5xy close parenthesis. So the first thing I'm going to do here is bring down the first polynomial, distribute the negative to the second polynomial, and then bring down the third polynomial. So the result is 5x squared plus 2xy minus y squared minus 9x squared plus 2y squared plus 7x squared plus 5xy. Next, I'm going to combine like terms. So I have 5x squared minus 9x squared plus 7x squared is 3x squared. Next, I have 2xy plus 5xy is 7xy. Finally, I have minus y squared plus 2y squared is y squared. The result is 3x squared plus 7xy plus y squared. Next, we have another practice problem. Perform the indicated operations. We have parenthesis 3x squared minus 2xy plus y squared close parenthesis minus parenthesis 7x squared minus y squared close parenthesis plus parenthesis 3xy minus 5y squared close parenthesis. Alright, so go ahead and pause the video, try out this problem, and then check back with the video after you finish. Alright, so let's go over the solutions. So first we bring down the first polynomial, and then we distribute the negative to the second polynomial, and then we bring down the third polynomial. The result is 3x squared minus 2xy plus y squared minus 7x squared plus y squared plus 3xy minus 5y squared. Next, we combine like terms. 3x squared minus 7x squared is minus 4x squared. Minus 2xy plus 3xy is plus xy. Y squared plus y squared minus 5y squared is minus 3y squared. The result is minus 4x squared plus xy minus 3y squared. For example number 8, evaluate the polynomial 3x squared y plus 2x squared y squared minus 5xy for x equals negative 2 and y equals negative 1. To evaluate the polynomial, we just substitute the value of negative 2 in for x and negative 1 in for y. We get 3 times negative 2 squared times negative 1 plus 2 times negative 2 squared times minus 1 squared minus 5 times negative 2 times negative 1. To simplify the expression, I'm going to first square the negative 2 in the first term, square the negative 2 and the negative 1 in the middle term, and then multiply the negative 2 and the negative 1 in the last term, and then bring down everything else. We get 3 times 4 times negative 1 plus 2 times 4 times 1 minus 5 times 2. Next, I'm going to multiply the 3 times 4 and the negative 1. This gives us negative 12. And then multiplying the 2 times 4 times 1 in the middle, this gives us positive 8. And then multiplying the 5 and the 2 at the end, we get negative 10. The result is negative 12 plus 8 minus 10. Next, we take negative 12 and add 8 to it. We get negative 4, and we bring down the negative 10. Simplifying this, we get the final result is negative 14. Next, we have a practice problem. Evaluate the polynomial 2a squared b plus 3a squared b squared minus 4ab for a equals negative 3 and b equals negative 1. Go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's get started. First, we substitute the value of negative 3 in for a and negative 1 in for b into the polynomial. We get 2 times negative 3 squared times negative 1 plus 3 times negative 3 squared times negative 1 squared minus 4 times negative 3 times negative 1. Simplifying the expression, we get 2 times 9 times negative 1 plus 3 times 9 times 1 minus 4 times 3. First, I'm going to multiply the 2 times 9 times negative 1. This is negative 18. Next, I'll multiply the 3 times 9 and the 1 to get positive 27. And at the end, I'm going to multiply negative 4 times 3, which is negative 12. The result is negative 18 plus 27 minus 12. Next, I'm going to combine negative 18 and 27 to give us 9, and then bring down the minus 12. 9 minus 12 is negative 3. So the final result is negative 3. For example number 9, the monthly revenue, capital R of X, in dollars from selling X clocks is given by the polynomial, capital R of X equals negative 0.3 x squared plus 90x. Evaluate the polynomial for x equaling 250 and describe the result in practical terms. To evaluate the polynomial, we just substitute in the value of 250 in for x. We get capital R of 250 equals negative 0.3 times 250 squared plus 90 times 250. First, I'm going to square the 250, and then I'll also multiply the 90 and the 250, and then bring down the negative 0.3. The result is negative 0.3 times 62,500 plus 22,500. Next, I'm going to multiply the negative 0.3 times 62,500. We get negative 18,750, and then we bring down the 22,500. Next, we go ahead and take negative 18,750 and add 22,500. The final result is 3,750. This means that the monthly revenue for selling 250 clocks is $3,750. Alright, so this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.